Now let's see this question. This question came in GATE 2015 for 1 mark. The question is, which one of the following is the recurrence equation for the worst case time complexity for quick sort algorithm for sorting n numbers? In the recurrence equations given in the options, C is a constant. Okay, so what is the worst case? We all know that what is the worst case, what can happen in a quicksort algorithm. So in quicksort algorithm, we typically take a list, and after that we choose some pivot. Generally we choose the first element as the pivot, and around this pivot we we split the entire all the elements of the list around this pivot. Okay, so whatever elements are smaller, they will come to the left of the pivot, and whatever other elements which are bigger than the pivot, they come to the right. So what is the worst case? What can happen? So if the list is already in sorted order, so if either the list is already in ascending sort or sorted or descending sorted, then the worst case can happen. Why? Because see, if 1 2 3 4 5 something like this list is there, then we choose, let's say, the first element as the pivot, then what will happen? This is the pivot and all the elements are bigger than 1, so they will lie on one side. So n minus, out of n elements, n minus 1 will lie on one side. Similarly, if 5 4 3 2 1 something like this list is there, then what is going to happen? That pivot, let's say we are choosing the first element as the pivot, then pivot is 5, and we split the entire list in such a way that all the elements which are smaller, they come towards the left, and bigger, they come towards the right. But 5 is the biggest one because this is already sorted in descending order. So if such a list we try to run quicksort on, then all these elements 4 3 2 1 will again come towards one side, so out of n minus 1 elements will again come towards one side. So my point is that here it is not going to divide it in equal parts or almost equal parts. Rather, one element at a time is going to be consumed, and rest of the elements are again going to come at one side, and we have to recursively run quicksort algorithm again on that. And since that list is again a sorted one, so that will also again traversed, and that will again be executed in such a way that one element comes towards one side pivot, and then rest of the elements again going to fall towards one side of the pivot. So my point is that if we write such a recurrence relation, then it is going to be something like Tn is equal to order n. So this is the time for doing a parse where we try to split it around the pivot, that is going to be order n, plus what is going to happen, that n minus 1 elements are going to lie on one side, so T of n minus 1. So recursively for n minus 1 elements we again have to run quicksort. So this is the recurrence relation, and this can be obviously written as something like Tn minus 1 plus order n can be written as something like C1n plus C2, where C1 and C2 are constants. Okay, so which of the these options correctly fit this pattern? This is basically B. So Tn minus 1 plus T1 plus Cn. T1 is basically you are doing something on one element, which is basically a constant time, and Cn, so where C is also a constant which is mentioned. So B is the only option which fits this paradigm, and that's why B is the answer.